用这样了吗？超过来了。
Okay, so thank you everyone for joining the session. So this session is mainly about we want to hammer out the what we believe the last kind of puzzles for NOVA cyborg interaction in Rocky. So here are just two main items that I want to cover. So the first item is Julie here and also Leo will introduce what we have done in Queens about the implementation of resource provider and resource tracker, all that stuff on the cyborg side, which we believe is complete, but we want to run it by the placement experts to see if there are like anything else left that we need to cover. And the second part is actually to ask the NOAA team to provide ideas on like if there are any needs on the NOAA side to, for example, change something or extend the API or whatever, or nothing needs to be done, is also fine. So we just want to get the professional idea from the NOAA team. Okay, so I will let Julie to lead the first part.
Okay, let me briefly introduce.
Can you see the fonts of
No.
I guess so.
Can you yourself see that?
Okay. Okay, man.
The colors, the highlights,
Okay, let me briefly introduce what we have done from cyborg for Queen release about the NOVA cyborg interaction. There are mainly three important features, which are accelerator API, data modeling, and the resource tracker. The resource tracker will run as a periodically task to discovery and report the resource to cyborg database through cyborg conductor service. So that's what we have done from cyborg to the NOVA and cyborg interaction. Our target of this topic is to provide accelerator resources to instance where attach and detach actions during the NOVA instance booting. In my opinion, I think there are three conditions must be satisfied first. The first one is cyborg should manage its accelerator resources via placement. And the second is cyborg should find a way to get the same hostname with NOVA compute hostname, which is the connection between parent and child resource providers in placement. And the third is a library probably called OSACC should be created to provide the attach and detach ability for accelerators.
I don't understand that part. What is the purpose of that library?
Are you targeting hypervisors other than
It's like OS break. So the majority of use case will be just PCIe, right? But there might be other protocols that we might use to do the attach, detach for the accelerators, like CCIX, high-speed cache, etc., etc.
Yeah, that's probably why they need some kind of generic interface.
Isn't this mostly going to be so? Because if you have a look at OSBIF and OSBRIC, they're more about driver interaction. Is the purpose of that going to be? Is OSAC going to live in cyborg, or is it going to be providing some XML to live there?
Yeah.
So is it going to be doing anything host related, or is it going to be doing something domain related?
I think the latter. So similar to OSBRIC.
So OSBRIC isn't allowed to generate any XML.
Yeah,
it's not allowed to do anything
only about the host.
And same with OSBIF.
Yeah.
They can only interact with the backends. It was one of the design constraints of OSBIF that we were not allowed to live with XML in any way, shape, or form.
Thank you.
No.
To be honest, what I would recommend is that if you go the way to have multiple kind of accelerator resources that you want to attach, that's you guys. You should actually provide the way to attach it to the guest, so that thanks to the library, then the XML could be generated to your information.
Okay.
刘局，施华博俊有快点有红包。
上河。
sorry.
Okay.
This is our colleague from Intel. 你不用，他也自己。
看。
你就继续。
Okay. If the three conditions are satisfied, the possible solution to create an instance with a accelerator device maybe like this. First, cyborg should register a resource provider as a child resource provider of Nova compute node resource provider, and with specific host name. Then, when Nova boot instance with accelerator request in flavor, Nova will query placement for availability resource providers with accelerator request. Then Nova will select the best host for booting in the allocation candidates, and passing down the request to Nova compute. The Nova compute calls the OSACC library to perform attach and detach actions. So that's the workflow about the instance with accelerators. Do you guys have any thoughts on this?
The first thing that comes to mind is selecting the actual node they're attaching these sub-resources to. So you said using the host name. Technically, Nova is using the host ID, which defaults to the host name, but isn't necessarily the host name. As the name of that node resource player.
Placement is mainly on the UUID.
So
I would
try to
get the UUID.
The UUID is the compute node UUID,
Right.
but the name is the host session.
I'm saying use a UUID and don't be too concerned if it's the compute node UUID. Just make sure it's the resource provider UUID. Because that may not be the compute node UUID, and that may not always be the thing that you want to parent your device to.
Yeah, but cyborg, as mentioned before, cyborg is going to report this FPGA resources on particular hosts, and we have to find a way to connect this host to the Nova reported host. So currently, only way is.
But you can't rely on hosting. So that value, the name of that compute resource provider is what the host ID is in the Nova config of that compute agent, and that defaults to the host name, but you can change that in the config.
Okay.
And at the moment, Nova and Neutron both have this in their configs for their agents, and they must agree, otherwise everything breaks. So you can't just assume it's a host. You have to have something in the config and just say operation when deploying this must match what's in the Nova config so that we can do the correlation.
Yeah, we talked this morning, and you know, this is getting way more detailed than one of the solutions we came up with, and that was simply to tag the different VFs that are the FPGA will provide with a trait that just says this is FPGA, this is capable of running these particular types of programs, and that's all that the request to Nova would have, because then cyborg would listen on notifications and then make sure that that particular VF is programmed appropriately, that the reprogramming was fairly lightweight and fast and not going to be a bottleneck.
I mean, yeah.
And that would simplify the whole placement and chain of everything. Mark that as FPGA.
Just to back up a little bit, because not everyone was in this morning's discussion. So cyborg has two problems. The first one is that they have to manage their resources, and those folks are the best guys who actually know what the resource is, because they have this kind of inventory engine or that kind of crazy stuff that runs on the hypervisor and actually looks at that and has the best knowledge. And this is not Nova which has the best knowledge. So if you consider that placement-wise, cyborg has to manage the inventories. Now the second question is, once cyborg identifies what's existing on the box, what's existing on the hypervisor, who or which project is responsible for defining on which specific compute that instance, how could I explain that? Who will make the allocation for that specific instance to that specific accelerator? And that is something which is like not yet fully solved.
Specifically, is cyborg or Nova responsible for doing the claim of resource against placement and updating it from time resource tracker state to this specific slot on the FPGA with multiple?
Yeah.
Yeah, so in other words, the inventory would just be generic programmable VFs. We wouldn't have the specific type of program as the
VF is assuming PCI bus or some kind of VF is assuming you have a PCI bus.
Well,
and you may not.
Yeah. But what I'm saying is that one of the ideas is that you have a resource class of MP program, you have a resource class of program A, resource, and actively manage those. And rather than do that, that would be useful if programming was a really like heavyweight activity and took up a lot of time and power, whatever. What we kind of concluded this morning was that that's not the case. It's much easier to simplify the resource tracking.
It depends.
Are we talking about locality of like picking an FPGA that's already got the image in it that you want?
Right, and then decrementing that, and then when they program one, they have to allocate them against the free one and create a.
To me, this is type of FPGA as a resource type, not the image that was in it, right?
Yeah.
Yep.
So you have type of FPGA, you have an inventory of them, you have a bunch of allocations. So when we go to schedule, we pick a list of hosts that have available inventory on the FPGA type that you want. And then there's a layer that picks, that orients them so that the ones that are most likely to have the image still in the FPGA go first, and we go that way, right?
Yeah. And then what would happen is that cyborg would then listen. We thought of sending a message, but this is easily listen on notifications for a particular image has been created, an instance has been created, and then check it. Say, do you have the right program on you? If not, boom,
That's
you know,
not
put it on for
necessarily
you.
okay because
You mean
it's
from
something
where?
either attach afterwards or that the application that's running can tolerate that the FPGA isn't programmed when it starts up. So you might actually need to block and wait to make sure it's
Yeah,
But that's like
that was the question this morning.
Right.
Because the question was whether it was needing to be blocking or not. And that really depends on the application that is running.
Whether it needs to be
It's like those
blocking in
computer
Nova.
Yeah, but that's a compute thing, right? Just like we don't start up the instance until the network is plumbed. If you've got an FPGA, we call the cyborg and we say, hey, here's the compute host that we landed this thing on. If it needs to be programmed or it doesn't need to be programmed, pull a host binding sort of activity, right? And then once it's available, and once network is available, and once the volume is available, then we allow the instance to boot.
Dan, I don't disagree. I just asked for that specific question, and the answer was, we don't see any kind of blocking situation. We are fine with totally asynchronous.
I don't think there's any way that makes sense.
It depends on the application type. If you're a cloud native FPGA application, the image is already programmed that you have a device, and it's a PCI device, presumably.
Mm-hmm.
If it's not, then you need to either program it over JPEG or network or some other interface. And that would be a blocking activity.
Okay, so make it blocking then.
You need it blocking on Nova.
It's
for the
blocking
instance.
the same way.
Yeah.
Okay.
It's blocking the same way. We could start instances with no networking, and they'll just get networking later, but we don't do that.
Mm-hmm.
It also be, I guess, to your request, Walker, you got the start with this pre-programmed image and then attach this other data. Maybe you have to attach the second image to the data or if you have
Sure, but then we just
that's two different calls.
We just don't do the attach until it's done programming. Just like we don't, I mean, we have to plumb the diff before we do the attach too. So.
Take a step back. We're not quite comfortable in the morning that it's okay to program every single time. Right? Program has multiple parts, not just the time to program, the security considerations, what the operator wants to allow in the cluster, and so on and so forth. So that could be a use case where you don't want to do the programming all the time.
Okay,
So,
but based on,
Yeah,
you were saying,
I'm just saying, no, we're all in agreement with the time because it's
that's,
I don't see it as a blocking issue. I mean, the thing is, you have your validated code, and that's what's going to be running on it. So you know what's going to be running on it. And
that's fine for your use case. I'm saying other use case as well. The good models where you don't
Yeah,
want to
but-
program all every single time.
no, you don't have to program it every single time. Just like you don't evacuate it every single time either. So you could potentially have it there already. The question is, do you have to pre-program everything before you actually do anything?
Right. So we talked about date binding our this
Yeah.
morning. So possible exposing just plain BS. So you can program every single time and not always work.
well, not that you would be prepared to program every single time.
Yeah.
You
You
may
don't
look
have to.
at it,
It's already
inspect
there.
it, and say, it's already there, and you're done.
You need to-
Yeah, user just wants, that's what he wants, that's it.
Right.
I think that's probably Dan's gesture that you have still got another way of it actually
Oh, that
technology is
would
right because you can wait to sort of the ones already
Yeah,
programmed.
that's the first one up. Yeah, we talked about adding a layer that could
Wait on what?
select the ones that are already there.
On what kind
On
of
the hosts that
things?
already have this type of FPGA slot available, and then you can also weigh on is it already programmed with the image that's requested.
So maybe that layer has to make a call to cyborg or that's
That's
Whatever
right,
it
but
needs
I
to
just
do.
wanted to make sure that this is not another thing. This is a outbound call to cyber. Just wanted to make sure.
Like you can run in like the Nova filter or the Nova filter.
No, I mean, what
what
I wouldn't like is to have like the no internal representation of what is the host to be modified for that specific purpose.
Yeah.
Okay. The problem was about saying so. So we say that cyborg manage the inventories, then it has to modify the flavor for requesting the specific kind of FPGA type, no?
Is it operator manages the flavor, right?
Yeah. When I said it has, the operator has to modify the flavor to match with the GPU trait.
Just like GPUs, right?
Yeah. Okay.
Yep.
So that's definitely one way to go through the image. One question I kind of had is, do you want to have this as a top level resource? Say when you go dash and make something, do you want to be able to say dash accelerator dynamically as a tenant, or do you want to keep this purely operator defined in the flavor, or you just
I would do it with flavor to start with. Yeah.
Just throw rope in this one. Also throw rope in this one.
Yeah.
When it's
Bad idea.
Hold on, you might get stuck.
Yeah, exactly. No, that's like it's just that they were closing it.
So one question is happening in the past couple of days is the user wants a specific accelerated video transcoding, for example. And it's not available, how are you going to handle that part? So it's one idea is to retry and so on.
No available, like, they're all in use right now.
Yes, it's not on
Just
use.
exactly the way it is. If you request 4 terabytes of disk and there's no disk available, you get no valid host, and you try again.
How do you retry it?
You run Nova boot again.
But it's user operation though.
Absolutely.
Yeah. So
Is
they
it
were
possible to have
talking-
a
It is. You would use Heat or something like that.
Yeah.
An orchestrator.
yeah.
Yeah.
They were saying use cyborg would be responsible for the
No.
orchestration, whether it uses heat and
No.
how it does it.
you
So
should have a
I missed
tool-
that. Sorry, Sam. Under what circumstances would it fail?
If there's none available. Just like if there's no disk available and no CPUs available and you boot something that's too big, we
Okay.
say no.
Yeah.
And then you're using an orchestrator like Heat or any other number of things that
And
are
then-
constantly trying to make the condition true that you asked for, it would.
So the user experience would be doing one of these. No, you can't have one of these, and then the user says to Cyborg, "I need one of these."
No, but again, so it's no valid hosts found back in the API, and then you just run the command again some more time later. So it succeeds.
It is 100. The user doesn't need to know anything about Cyborg in that case, right? They literally, I might boot an instance and ask for m1.huge. I boot it. There's no space available in cloud. I get a no valid host. I could try again. I could probably wait a little bit and then maybe boot one and get one the exact same work.
Well, how would you know that's the problem when you try again? How would you magically know?
But
what based on what parameter?
It's the exact same situation as not having enough of any other resource.
Yeah.
As a user, you don't exactly know why you got that specific resource usage problem. Because that's a flavor.
So is Cyborg able to create resources? Cyborg is able to create resources, isn't it?
Yeah. Able to create inventory that
Yeah.
makes Nova think that available resources on.
So that was why I was talking about making a second. I
But
see
the
none of
user-
these. Give me one of those, and then try again.
The user doesn't go to Cyborg to open up more space, right?
Cyborg will notice or something that there's.
Well,
not
you're
enough of those
assuming that.
things and-
So this is still a programming, right? So you're saying in this case, I'm asking for something. I think the use case you have for is IPsec is already programmed. There's no IPsec capable images available. Cyborg would find something that can do it, provision it, and then create a new resource provider. But I think you're better off if you want Cyborg to do that. Keep Cyborg do that, and then have the user just retry it as normal.
Well,
might get lucky.
if Nova, if you have a completely empty cloud that has no FPGA with any existing image in it, right? I boot a video transcoding flavor, right? We do a request a placement. We say we need compute hosts with this many CPUs, this much RAM, and a fmaster 9000 FPGA in it. Then we pass it on to the weigher, and the weigher looks at all of the hosts that were returned with an fmaster 9000 FPGA, and it sees none of them have the image, so it doesn't weigh them differently at all. We send that request down to Nova Compute for that host that has that FPGA, and as a part of the process of booting the instance, just like we call to Neutron to set up the network and send it to set up the volume, we call to Cyborg and we say, hey, they've requested this image, and it says, does it already have that image? No, it doesn't, so I'll program it. Hang on a sec. And we're waiting, just like we would wait for a volume to be created. And then once it's done, we continue to boot.
If the request bit asks for a particular device like the national in the case, how do you know it's asking requires video transcoding accelerator actually? Where is it?
It would have to also have like an image for the acceleration or
In the flavor,
yeah,
some sort of key in extra specs that says FPGA image ID is video transcoding. And so that way we're asking placement for the hardware, we're asking Cyborg for the image.
So if you prefer, the operator could ask the Cyborg API to give to exactly know all the extra specs values that he has to modify into. Sure. Like saying, okay, so I want to manage some specific FPGA type. This cyborg gives me all the FPGA types I can put in my flavor. And then you could say, just modify this and this. And then so he makes sure that when a user uses that specific flavor, it got that specific FPGA type.
FPGA type with that FPGA image in it.
So
because the resources, it'll be a resources key to get an FMaster 9000. It'll be a different key that will say, and in that FMaster 9000, I want the video pirating code. It's two things.
Yeah.
It's kind of like saying to Cinder, kind of, I want a 40 terabyte image or a 40 terabyte volume, and in that volume, I want you to go ahead and lay down this image inside of it. It's the same thing. We don't currently do that in the flavor right now, but I'm saying it's the same. The container and the thing that goes inside it.
Okay. That's probably why you actually lost me, because I was thinking that from a pure resource class perspective, we are saying that all same FPGA types are treated as equal.
No. FPGA, the hardware.
I mean, all the same FPGAs sharing the same type were treated as equal, and if the image wasn't there, then it was fine.
Yeah, correct. Because it can either be, you want to use an FPGA that's already got the image in it,
yeah.
But if you don't have one, then you're going to program it.
Sure, but if we say that the extra spec key will include that specific image, then we could end up having no.
No, it's saying the one that you want eventually on the hardware.
So you mean two keys?
Yes, two keys. One for the hardware type and one for the image.
Okay, so for the hard type, it would be done by placement, and for the specific image, you will put away.
Yeah,
my bad.
Exactly.
And in this model, the allocation itself is done at the same time as the allocation for it, so it's done by Nova.
It's done by the scheduler at the same time we reserve all the other. So by the time you get to the compute, you've got the FPGA waiting for you.
That's really well.
And who was responsible for creating the resource provider associated with the FPGA?
I think that Cyborg, much like Cinder and much like Neutron, should create a child resource provider on the compute node parent resource provider with an inventory of the type. So if this compute has two types of FPGAs, then it will create two children, each with inventory of the two different types.
Exactly like virtual GPU stuff.
And exactly like Cinder should be doing, and exactly like should be doing.
And that can only handle the traits.
Just for my own understanding, this would be then so Cyborg isn't doing any dynamic resource creation. This is a thing that you expect your compute host to boot Cyborg to find its stuff, and that will never to change.
Pretty much, unless you are hot plugging FPGAs.
Yeah.
Right, and is there a hot plug path that we're
Should you open again?
Yeah. Hot plug path. I'm sorry, it's an attach detach on an existing instance.
Same sort of deal, right?
So still Nova is responsible for creating the allocation.
In the attached case, before we even involve the compute node, we can go and try to add an allocation for the type that and we can fail the API immediately if that doesn't work instead of even getting the compute involved.
Right.
Whereas right now,
and Cyborg doesn't get involved with that.
Right.
Okay.
Yep. Thanks, guys.
So to the Cyborg people, I mean, are you following the gist of everything? I just want to make sure that we're not getting lost in Nova placement plan and confusing the hell out of all of you.
Okay, let me try to recap, see if I understand everything. You could potentially put a trait like an FPGA, as a FPGA kind of thing, put in a request spec, and the extra spec to say what function you want. It's image or video class.
Is function the right word? I'm saying image, but
right, whatever it may be. Right?
Okay.
Ask for the function.
Capability. Let's use that.
No. Function.
No, this looks only at the trait. It's going to select all the photos of FPGAs in it, and subsequently some filter where actually looks at extra specs and put it down further based on the request function.
Yes. So you're going to request two things in it. It's going to have the model of the FPGA and then the thing that you want inside of the function. So placement is concerned with the model, and then the Nova where is concerned with the function.
But do we even calculate the model at this point? Could this be FPGA in general?
What's
I
your
don't know,
What
doesn't it
was-
matter?
That's probably left to cyborg, right? Cyborg and the filter talks to cyborg is on form.
Doesn't the function, this is why I was saying image. I would assume that if you have an Intel FPGA and an NVIDIA FPGA, that you can't just load something that's native code here into this circle.
That's true, correct.
Yeah.
So the function UID has somehow select which device it's matching to.
Yeah, so the function would have to be an image per instance or per card, so to speak.
I would
Have
expect,
requirements.
I would think, yeah, I would think that the resource provider that you associate with the FPGA is going to have a trait indicating that it is capable of a certain kind of program.
yeah. So it could be speaks Intel, and it could be any of the Intel FPGAs, or it could be an Intel 7, whereas an Intel 8 needs to be a different thing. That's
The
up to
only
you.
reason why I'm staying with the FPGA model type, so the end user perspective is gobbledygook.
Oh,
I
yeah.
want IPsec. I don't want FPGA model 7.
The end user doesn't see
Exactly.
any of this. The operator sets this up in the flavor and then calls the flavor a video transcoding flavor. And that's
Oh,
all,
that-
or an IP
so
set
that-
flavor.
That works too. Sure.
On that though, you have now restricted to bring your own image format. So I can't write my own bitstream, like physically develop this locally and then go to a cloud provider that provides that type of FPGA, upload this and connect it with control to the
You can if the
if it's supported in the image as well. Then
do,
maybe.
do people want to make that available
Yes.
to untrusted people?
That's the primary use case, I'd say.
Right.
Actually, this is a secondary use case we're discussing right now.
Okay. Oh,
I don't
really?
like as much, actually. That's the other one.
The
It's valid for a private cloud.
you don't like the case of flavor that says I do video transcoding, you mean?
Not as much because it could be defined at runtime, right? If you have an FPGA, it could be anything. And it's up to the user at the last minute, or it's up to the user to decide what's essentially programmed on it. Could be transcoding, could be IPsec, could be whatever.
Okay. Well, that
Would be the
There
most
are different
used
use cases. Which one is primary or secondary?
what interaction does Cyborg have in that case? If we know to put an instance on a host with an FPGA, and we get enough information from Cyborg to attach that FPGA into the guest, I mean, does Cyborg have anything else to do with it at all?
Cyborg will read out some metadata on the FPGA already from a image that's flashed as a sort of firmware. And then find a matching bit stream that is able to program to it. Could be n number of IP vendor bit streams that could go on from the image database.
So I thought you said that the user can then program it later.
That is also true.
Okay, I'm talking about the user programming case. So assuming we've solved the Cyborg puts an image on it for you case. In the case where the user is going to program it, if the operator allows that to happen and wants to expose that in the flavor, they can say, and this has a
Image equals none.
image equals none, and this is a foobar type FPGA. That's what you're going to get. You can do it when you have it. Then we just don't do the image step, right?
Yeah. So the user can ingest their own image and program it.
Sure. I just assume that you want.
Yeah,
If we solve the complicated case, you can solve the less complicated case of, and I blew it away with whatever I want.
but in the first case, unless I've misunderstood, you want to restrict which function the user can put on the FPGA, right? So you want to presumably present it to the guest in some manner which prevents it from being reflashed.
That's usually a limitation of package virtualization of the FPGA.
Yeah,
So usually you can only do the programming through the PF, and that's obviously device specific. So the VF is able to consume what's programmed on it, so the PF is required to actually be imaged.
So if you're handing them the PF, you're assuming they can do what they want with it.
Yeah.
If you hand them only a PF, but that's we asked Cyborg what is the thing that we want to attach to the guest, and you told us. So
Yeah, and there's kind of two use cases here. The orchestrator programs it, either with an image that the operator has set up or that the tenant was provided. I'm giving you an FPGA as a tenant that you can do whatever you like with it. Is the entire FPGA I've done basically a PCI pass-through of it. Could be other protocols. Go nuts and program it.
So should we do the same thing that we do for NICs and call a
Like
FPGA? Well, no, a VF and a PF are two different resource types. So that if you are looking for a compute host with a whole PF, we need to know that, right? So that we can give you a compute host that's got an empty PF, whereas if you only need a VF, you might co-locate with someone that's already got the IPsec thing.
But actually, that's cyborg. We will actually create the resource classes. So I mean,
It does.
Yeah.
It does. For sure. So it doesn't
it doesn't matter for
Yeah.
the line. Well, that's what I'm trying to explain.
Well, it will not Nova potentially because it may affect the hypervisor definition, like the little XML or whatever you're passing to us, because it may need to pass through the visor definition.
Sure, but actually, since we would then call the cyborg API to what to plug.
Presumably, we're going to ask for a PCI ID or some other sort of handle.
Yeah.
And that negotiation would be either OS brick or OS VIP type, shared knowledge of.
So one of the questions that came up before you came in was, again, OS VIP and OS BIPs are not allowed to touch the hypervisor or XML definition. How do we do it in this case? So obviously, we're going to have to ask Cyborg for how do we virtualize this, and then Nova will generate the corresponding.
Yeah. So let's not write that code here. Let's get some code proposed that shows us what it looks like, what are the terms that we're talking of, and we'll try to figure out an abstraction or something.
Well, the other thing worth to point out is, well, it's possible to pass through multiple functions.
Yeah, that's okay.
That's fine. Yeah.
That's fine. Just like we have multiple links. I think that doesn't change anything we just talked about.
As long as we have granular.
Yeah.
And yesterday you were talking about affinity issue as well between the different things.
Right.
With the weighing filter, you should be able to prioritize things that are closer together.
Stop saying weighing filters. Just say filtering weight. I don't know.
Oh yeah, filtering weight. Yeah.
So on that point, so simplistically, we're booting a Nova is booting a new instance. It's got an FPGA and we're putting an image on it. So Nova discovers that the image isn't currently there, function whatever. It tells something to put the function there. How does Nova then communicate the fact that it did that, such that it can be later considered by the weighing filter?
We asked Cyborg to do it. Cyborg did it, and then now Cyborg's filter, which is querying Cyborg, or Cyborg's weigher, which is querying Cyborg, now sees that that image is now on that thing.
Okay, so that's Cyborg's problem. So Nova doesn't have to stick that in a resource tracker.
Correct. The French guy said that's all on Cyborg's side. You said that's Cyborg's problem, but it is the same deal.
Okay, all right.
That's not the problem.
It's French. One question. If we do this in the filter, are we now blocking in the scheduler? Like we can be a bit of defense during the way up, but we are effectively blocking at that point.
Yes.
Waiting.
Yep.
Yeah, but the flashing is not going to happen in the filter.
No. Just the select, the calling to Cyborg.
Usually, so this would have to be the last way up because we haven't actually selected the host yet at that point. But I'm going through the host.
The way is just checking it's already there.
No, yeah, the weigher is just taking all of the hosts that we've got and figuring out which one is the best.
Right. Oh, so that way it would always return just one host, the one that was spoken.
No. It's going to return 3 hosts that already have it and 10 hosts that don't have it, and Nova is going to try to choose this one first, and that will likely get you one that already has it programmed. But if this fails and this fails and this fails, you might get number 4, which doesn't have it, but that you've already done your prioritization.
I was just wondering whether the programming happens. In that case, the blocking for the programming to complete it
happens on the compute node, way along
during spawn,
which is where we block things.
Yeah.
So there's something that y'all were talking about yesterday that I think the decision that was just made, I guess, was going to throw a monkey wrench into, which is that you guys were talking about doing a reservation first and then an allocation later. And we don't have a way for you to do that. If Nova is handling the allocation, then we don't have a way for you to do that.
No, but you can actually ask the cyborg API if you want to because, for example, say you would like to open your cloud to the users, and you know that, for example, for today you will have like a huge number of people asking for some specific crazy stuff. You could just ask Cyborg to prepare your FPGAs just by reprogramming that.
That's not the point of the reservations. I mean, I don't think it was. The point of the reservations was to avoid for quota and to avoid trace conditions, right? And that doesn't help for this.
Sure, I get it.
Yeah, so, and you can't you're not gonna be able to reserve, and then you'd have to like unreserve real quick.
Sure, but the reservation mechanism is something we don't do now. That's done elsewhere.
But it can't be done in this scenario. There's no way to make that happen.
It can with even over.
But I don't see why there's a huge problem. Mainly because I think I don't see this, but you can put your reservation in cyborg that says I want to have or reserve 10 IPsec instances or 10 IPsec regions. Then when you go right down to the spawn point, there it can atomically decrease that.
Well, no, so
that's not where it happens.
When you're doing the reservation, are you reserving a specific one, or are you just saying I want 10 things, and we'll figure out which ones at the time?
Wait. I think we're purely introducing a new system in place by saying we would like to block some specific resource on some specific amount of time, and I just feel this is not something that we should really go in that direction.
Yeah. It's possible, but it's
other people are solving that specific problem.
I wish will not block.
Right.
Not me, but yeah. Put it in the computer.
Well, what I mean is, instead of blocking, why not fail if you can't reserve?
Well, that will happen. If you try to schedule a node that can't get a resource, it will fail to schedule. But I assume what they want to do is reserve that this tenant will have 4 IPsec FPGAs available if they go between the hours of 10 and 2 to do it, and that's a thing that Nova doesn't do. And other people want to do it for other types of resources.
Time reservation rather than quota.
That's maybe a cyborg
From the presentation before, like just making sure we actually have that amount of FPGAs before you actually run.
Yeah, so it doesn't help for race.
No, you can't do that.
Yeah. So if race is not an issue, then fine. But if we're trying to
Well, within the allocations and the schedule of our placements, we are allocating them, not the specific instance before we ever get to compute them. So they're not.
Then also before we ever get to cyborg.
In Nova, the way you
Which is
reserve
not-
something
which
is
is
you
not
boot
what
an instance into that hole.
Right.
And don't do anything with it. So if that's what you want to do, then cool.
So with this approach, you have one flavor for every combination of FPGA type and image type. Are you concerned about flavor explosion?
I'm not, but you might be.
This is why I love the question of, should we also do this by an image metadata, or should we also have just -- accelerator and some other stuff and we'll do
That
do it
maybe
dynamically?
later, but not now. Just
Yeah,
wait.
sure. But like, they're the 2 other options.
So, in an image, you can override certain flavor properties already.
Yeah.
So we can allow this to, it makes sense for a flavor to have a particular model of FPGA hardware, and for an image to say, I want installed in my FPGA an IPsec.